A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Imagine you are an author, and you have this brilliant idea for a 100,000-word epic novel. You sit down at your desk, but there is a catch. Your typewriter only lets you see the last 5 pages you wrote, and it physically stops working after you hit page 10. To keep going, you have to stand up, walk out of the room, come back in, and somehow remember exactly where the plot was, what color the protagonist's eyes were, and why there was a mysterious silver key in Chapter 2. This is the exact paradox we are facing with large language models today. We have these massive input windows where a model can read a whole library, but when it comes to actually generating content, there is a hard ceiling. It is like having the world's most sophisticated brain attached to a hand that gets a cramp after writing a postcard.
Herman Poppleberry here. That is a perfect way to frame it, Corn. We are living in this era of 2 million token context windows for models like Gemini 1.5 Pro or the newer Claude models, but the output limit is the stubborn anchor. Even in early 26, most frontier models are still hitting a wall at around 4,000 to 8,000 tokens for a single response. If you ask a model to write a novel, it cannot just stream out 250,000 words in one go. It physically cannot. So the question remains, how do we build agentic workflows that maintain task guidance over a long horizon? How does the agent remember it is writing a mystery in Chapter 20 if it finished Chapter 110 API calls ago?
It is a fascinating problem because it moves the challenge from model capability to architectural design. Today's prompt from Daniel hits right at the heart of this. He is asking about how that moving task context is achieved in agentic workflows when the output length is a hard constraint. By the way, today's episode is powered by Google Gemini 3 Flash, which is actually handling the script for us right now. It is a bit meta, considering we are talking about how these models manage complex instructions.
It really is. And to Daniel's point, we have to distinguish between input context, what the model can see, and persistent task context, which is the evolving state of the job being done. When you are building an agent to do something complex, like writing a novel or managing a massive software migration, you aren't just sending a prompt, you are managing a state machine. The memory isn't just in the model's weights, it is in the scaffolding we build around it.
So let's break that down. If I am an agentic orchestrator and I need to write this novel, I can't just say, go. I have to manage the moving context. What is the first line of defense there? Is it just cramming a summary of the previous chapter into the next prompt?
That is the naive version, often called prompt carryover, but it fails pretty quickly for complex tasks. If you just summarize, you lose the texture. Think about the lossy compression problem. If you summarize Chapter 1, you might say, John walked through a dark forest and felt scared. But in Chapter 2, you need to know why he was scared. Was it the sound of a snapping twig? Was it a childhood trauma triggered by the smell of pine? A summary kills those details. The first real mechanism professional developers use is state serialization. Think of this as the story Bible approach. Instead of just passing raw text, the agent maintains a structured file, usually in JSON or YAML, that acts as the ground truth for the entire project. This file contains the global state. In a novel, that would be character descriptions, plot points already resolved, and open loops that still need to be addressed.
I like that because it makes the memory machine readable. If you just ask an AI to remember the plot, it might hallucinate that the hero's dog died in Chapter 3 when he's actually sitting right there in Chapter 4. But if you have a JSON entry that says dog status alive, It is much harder for the model to drift. But Herman, how does the agent actually interact with that JSON file? Does it read the whole thing every time?
Not necessarily. Before the agent starts writing Chapter 5, the orchestrator reads that JSON file, filters for only the active plot lines, and injects the relevant bits into the system prompt. It says, based on this state, write the next 2,000 words. It's like a briefing before a mission. But Herman, even with a story Bible, you hit a limit. If the Bible gets too big, you are back to square one, eating up your input context with metadata. Imagine a Bible that tracks every minor character in an epic with 500 named individuals. You'd spend 40,000 tokens just explaining who everyone is before you even write a single word of dialogue.
It's the metadata bloat problem. If your instructions are longer than your creative output, you're essentially paying for the AI to read a manual rather than do the work. So, what's the move when the story Bible itself starts to burst at the seams?
That is where mechanism 2 comes in, external memory stores, or what people often call RAG for agents. Instead of putting the whole story Bible in every prompt, the agent uses a vector database or a key value store. This is crucial for long horizon tasks. Let's say the agent is writing Chapter 20 and needs to reference a specific conversation from Chapter 2 about a silver key. It doesn't need to hold Chapter 2 in its active memory. It performs a semantic search against its own previous outputs, retrieves the relevant memory, and brings it into the current thought space. A study by the AI Engineering Institute in 25 showed that agentic systems using this kind of explicit state management were 3 times more likely to finish a long task without losing the plot compared to systems just winging it with simple summaries.
3 times? That is a massive delta. It basically means the difference between a coherent book and a pile of gibberish. It reminds me of how a human writer works. You have your sticky notes, your character sheets, and your previous chapters sitting on the shelf. You don't have the whole book memorized perfectly at every second. You just know where to look. But let's talk about the actual writing part. If the model can only output 8,000 tokens, and a chapter is 5,000, the model is already exhausted just finishing one segment. How do you handle the recursive task decomposition Daniel mentioned?
This is where it gets really nerdy, but incredibly cool. There is a framework called Right Here that came out recently. It stands for Heterogeneous Recursive Planning. The idea is that you don't just have one agent writing. You have an orchestrator that acts like a lead editor. The orchestrator doesn't write prose, it writes plans. It breaks the goal. Write a novel into write chapter 1, then further breaks that into scene 1, scene 2, and so on. Each of these subtasks is small enough to fit comfortably within the output limit. Because each subtask is discrete, the model can dedicate all its reasoning energy to that one piece, rather than trying to juggle the entire architecture of the book at once.
Wait, so the orchestrator is essentially managing the context budget? If scene 1 is about a high-speed chase, the orchestrator tells the worker agent, focus only on the physics of the cars and the tension of the driver. It doesn't tell it about the hero's grandmother's secret recipe in chapter 12, because that's irrelevant to the current output window.
Precisely. It's about attention management. By narrowing the scope of the output, you actually increase the quality. It's the difference between asking someone to tell me the history of the world versus tell me what happened in Paris on the morning of July 14th, 1789. The second prompt will give you much more vivid, usable detail because the model isn't trying to compress a billion years of history into a few thousand words.
It is like the divide and conquer algorithm for creativity. But there is a cheeky edge to this, isn't there? If you break it down too much, don't you lose the flow? If Agent A writes scene 1 and Agent B writes scene 2, how do you make sure the prose doesn't feel like it was written by a committee of robots who haven't met? I've seen this in early AI-generated scripts where one character sounds like a Victorian poet in one scene and a streetwise detective in the next.
You've hit on the context drift problem, corn. It is a major second-order effect. When you serialize state like turning a scene into a summary and back into a scene, you are basically playing a game of telephone. Subtle errors accumulate. Maybe in scene 1 the character is anxious, but the summary just says he talked to his mom. By scene 2, the agent thinks he is perfectly calm because the anxiety wasn't serialized in the state file. To fix this, you use evaluator optimizer loops. After a worker agent finishes a scene, an editor agent, which has access to the full story Bible and the previous scene's raw text reviews it. It looks for state violations. If it finds one, it sends it back with a correction prompt.
So it is essentially a high-tech version of trust, but verify. You have one agent doing the work and another one acting as the consistency police. Does the editor agent have its own separate memory, or is it looking at the same JSON Bible?
It usually looks at the same Bible but has a different system instruction. While the writer is told to be creative and descriptive, the editor is told to be pedantic and critical. The editor's job is to look at the writer's output and ask, does this match the established facts? Is the tone consistent with chapter 1? Did the characters suddenly forget they were holding a gun? If the editor sees a mistake, it doesn't just fix it, it provides feedback to the writer for a second pass. This multi-agent debate is how you bridge the gap between short outputs and long-form coherence.
I can see how that would be expensive, though. If you are doing 3 or 4 API calls for every 1,000 words of final output, your token bill is going to be astronomical. It is not just about the final novel, it is about the thinking, tokens used to get there. We are talking about a 10-to-1 or even 50-to-1 ratio of internal tokens to published tokens.
Oh, the cost is a massive factor. For every 1,000 words of polished prose, you might be burning 100,000 tokens in reasoning, planning, and editing. But that is the price of consistency. What I find wild is the conciseness bias. LLMs are trained to be helpful and brief. If you give a model the whole plot and say, write chapter 1, it will often try to finish the whole chapter in 3 paragraphs. It rushes to the finish line because its training data says, answer the user's question quickly. To get a real novel, you have to force the agent to write in beats. You tell it, write the next 500 words focusing only on the description of the room. Then, write the next 500 words of dialogue. You have to micromanage the pacing because the model's natural instinct is to summarize.
It is like trying to get a hyperactive kid to write a long-form essay. They just want to give you the TL, DR, and go play outside. The hero went to the cave, got the sword, and killed the dragon. The end. Can I have a cookie now? You really have to hold their hand through the process. But let's look at the story Bible as a living document. In these agentic workflows, is the Bible static, or does the agent update it as it goes? What happens if the AI has a stroke of genius mid-chapter?
It has to be dynamic. This is what the Right Here framework calls interleaving execution. If, while writing chapter 5, the agent decides it would be way cooler if the protagonist has a secret twin, it can't just write that and move on. It has to trigger a state update task. The orchestrator pauses the writing, calls a reasoning model to update the story Bible, checks for contradictions in previous chapters, and then resumes. The Bible is the single source of truth. If the text says one thing and the Bible says another, the system breaks. This is why frameworks like LangGraph or Crew AI are becoming so popular. They give developers the tools to manage this global state explicitly.
I remember we touched on some of the stateful agent stuff in our discussion on LangGraph a while back, specifically how it handles those cycles. But here, the scale is just different. We are talking about thousands of state transitions. It makes me wonder about the lost in the middle phenomenon. Even if we have these massive 2 million token windows, does the model actually see the story Bible clearly if it is buried in a mountain of other data? If the Bible is at the beginning of a massive prompt, does the model lose the thread by the time it gets to the end?
Research actually suggests that for agentic workflows, smaller is often better. If you give a model a 100,000 token prompt, its performance on specific instructions can degrade. It gets distracted. It's like trying to listen to a whisper in a crowded stadium. Most high-end agent architectures actually prefer context distillation. Instead of giving the model the whole book, you give it a distilled version of the current state. You provide the high-level outline, the immediate previous scene, and the relevant character facts. This sparse context keeps the model's attention focused. It is a counterintuitive insight. As context windows get larger, the most effective agents might actually use them less for raw data and more for thinking space.
That is a sharp point. Just because you can fit a whole library in your head doesn't mean you can think clearly while trying to read every book at once. It is about relevant attention. So, let's play this out. If I'm building a software coding agent rather than a novelist, how does moving context work there? Is the story Bible just the code base?
In coding, the state is the file tree and the function signatures. If the agent is refactoring a database module, it doesn't need to read the CSS for the front-end login page. The orchestrator prunes the context to only show the relevant API endpoints and the specific file being edited. Then, after the edit, a linter or test agent runs to see if the state update broke anything. If the test passed the global state, the codebase is updated. It's the same pattern: plan, execute, verify, update state.
So, if someone listening wants to build something like this, maybe not a novel, but a complex agent for their business, what is the takeaway here? How do they avoid the output limit trap?
The first takeaway is, never rely on the model's implicit memory. If you are doing a task that takes more than one prompt, you need an explicit state store. Whether that is a JSON file on your hard drive, a row in a Postgres database, or a vector store, you need a place where the truth lives outside the LLM. Use structured serialization like JSON or YAML. It is much easier to verify character allocation London than it is to parse a paragraph of natural language to see if the AI forgot where the hero is.
And the second takeaway has to be recursive decomposition. Don't ask the AI to write the report. Ask the AI to outline the report, then research section 1, then draft section 1. By breaking the output into segments that are well below the hard limit, say 2,000 tokens each, you give the model the headroom to be detailed and creative without it hitting that "I need to finish this now" wall.
And don't be afraid of agentic redundancy. Have an editor agent. It feels like a waste of tokens, but in a long horizon task, the cost of failure is cumulative. If Chapter 2 is bad, Chapter 3 will be worse because it is building on a shaky foundation. Fixing errors early in the moving context is much cheaper than trying to rewrite a whole novel because you realized at the end that the protagonist's name changed 3 times.
It is the measure twice, cut once philosophy of AI engineering. I also think there is a real aha moment here regarding the difference between input and state. We often get blinded by these million token marketing headlines, but for an agent, the limiting factor isn't what it can read, it is how it manages what it has already done. The output limit is actually a blessing in disguise because it forces us to build modular, verifiable systems instead of just throwing a giant prompt into a black box and hoping for the best.
I love that perspective. The constraint breeds better architecture. It forces us to act like engineers rather than just prompt whisperers. We are building cognitive architectures where the LLM is just the processor, but the memory and the bus and the storage are all external. That is how you get a novel. That is how you get an agent that can code a whole app. You move the intelligence from the model's single response into the system's overall workflow. It's essentially building a computer where the LLM is the CPU, but you're the one who has to design the RAM and the hard drive.
It's funny you say that, because in the early days of computing, programmers had to be incredibly clever with how they used limited memory. They had to swap data in and out of the processor. We're doing the same thing with context swapping in LLMs. We're going back to the future of computer science.
We really are. The context window is just the new registers or L1 cache. If it's not in the window, the model can't think about it. So your job as the architect is to make sure the right data is in the right register at the right time.
It makes me wonder where this goes in the next year or two. Will we see stateful LLMs where the story Bible is actually baked into the model's KV cache or something? Or will we always be managing this external scaffolding? There are some experimental models trying to implement infinite context through recurrent layers, but they always seem to lose precision compared to the transformers we use now.
There is research into long-term context models that can checkpoint their state, but for now, the agentic workflow approach is winning because it is transparent. You can open that JSON file and see exactly what the agent thinks the plot is. You can't do that with a model's hidden weights. For production systems, that observability is everything. If the agent starts making mistakes, you can look at the state log and see exactly where it went off the rails. You can say, here in Chapter 7, the state update failed to record that the protagonist lost his keys. You can manually fix the JSON and the agent is back on track. You can't edit a model's internal memory like that.
It is the difference between a wizard and a scientist. I'd rather have the scientist with the notebook than the wizard who might forget the spell halfway through. This has been a deep dive, but I think it really clarifies why Daniel's question is so vital. It is not about the size of the AI, it is about how you orchestrate its movements. It's about the choreography of information.
Well said, and honestly, it makes the prospect of AI-written novels a lot more interesting. It is not just a random text generator anymore, it is a collaborative planning system. I'm genuinely excited to see the first truly great agentically authored epic. It will be a triumph of architecture as much as a triumph of language. We might even see a new genre of architectural literature, where the design of the agent's state space is as important as the prose itself.
Well, if it is a mystery novel, I just hope the agent remembers who the killer is by chapter 30. If not, we are going to have a lot of very frustrated readers. And the murderer was... Wait, let me check my vector database. Yes, the butler.
The butler, who was actually a secret twin, added in a state update call in chapter 12.
Precisely. Well, I think we've unpacked the moving task context quite a bit today. It is all about the scaffolding, the story Bible, and the recursive breakdown. If you are building agents, don't just prompt program the state. Think of yourself as the director of a movie, where the LLM is an actor who has a very short-term memory. You need to provide the script, the props, and the continuity person to make sure everything stays on track.
And keep an eye on those thinking tokens. They are the silent engine of the whole operation. They are the CPU cycles of the 21st century.
Thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes. And a big thanks to Modal for providing the GPU credits that power this show's generation pipeline. This has been episode 1989 of My Weird Prompts.
If you found this helpful, or if you're building your own agentic workflows, we'd love to hear about it. Find us at myweirdprompts.com for the RSS feed and all the ways to subscribe. We're always looking for new prompts that push the boundaries of what these models can do.
Until next time, keep your context clear and your states serialized. Goodbye.
Goodbye.
This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where